Okay, so we're going to solve a couple of simultaneous equations using the substitution method. Okay, so we've been told to use the substitution method. So what we're going to do is, the first one's pretty simple. What we're going to do is we're going to substitute our y equal to x into equation 2. So we call this equation 1 and this one equation 2. So we're going to say sub y equal to x into equation 2. Now, essentially what we're doing there is whenever we see a y, and we see this y here in the second equation, instead of writing y, we're going to write x, because that's what we said in the first equation, y and x are the same. So if I rewrite equation 2, 4x plus 3, but where I see y now, instead I'm going to write x equals 7, we've now got an equation that we can actually solve. So the way we do that is say, okay, well 4x plus 3x is 7x, which is equal to 7, and then we divide both sides by 7. Dividing both sides by 7, we get that x is equal to 1. Now that's solved for x. We've also got to solve for y. Well, we can solve for y by substituting back up into either of the first equation or the second equation. Well, let's do it into the first equation. So sub x equal to 1 into equation 1. Well, that's just simply y equals 1. So you say, therefore, the simultaneous, and let's make it a bit bigger, simultaneous solution is x equal to 1 and y equal to 1. Now, if we're trying to solve for the second one, are you still with me? Are we still recording? How do I tell? Yes, we are. Fantastic. Alright, so if we want to solve for the second one, let's call this equation 1 and this one equation 2. Okay, and again we're going to do substitution. So we're going to sub x from equation 1 into equation 2. So what we're going to do is we're going to rewrite equation 2, but where we see x in equation 2, instead of writing x, we're going to write 4y plus 1. So I'm going to rewrite equation 2. It's 2y minus 3. Now I've got to the x part of that. So I've written 2y minus 3. Now I'm getting to the x part. Instead of writing x, I'm writing 4y plus 1. But 3x means 3 times by x. So I've actually got to times by that expression there, 4y plus 1. So you can see I've written the first part of that equation up to there so far, but instead of writing x, that was x, that part there, I've written that x there as being that expression there. So I've got to finish off writing this equation now, which was equals negative 23. That was the end of equation 2. Now I should be able to solve for this, okay, because I've got it all in terms of y. So I'm going to expand these brackets, so I'm going to keep this as 2y. Now, when I expand this bracket here, I'm going to go negative 3 times by 4y. Well, negative 3 times by 4 is negative 12, and then I've got y on the end of that, so negative 12y for the first part. Then I've got negative 3 times by positive 1. Negative times a positive is a negative. 3 times by 1 is 3, equals negative 23. Let's keep on going with that. Let's tidy up first of all our y's, collect like terms. We've got positive 2y minus 12y. That's minus 10y. And we've got minus 3 there, which can't go with the y's. So we've tidied up the like terms. Now it's a matter of solving this equation. Well, first of all, we've got to add 3 to both sides. When we add 3 to both sides, we're left with negative 10y on this side. And over on this side, negative 23 plus 3 is negative 20. Now we can finally solve it. We solve it by getting rid of the times negative 10x by dividing negative 10x on both sides. That cancels these negatives and the 10s out and leaves us with just y equal to, now negative and a negative make a positive, 20 divided by 10 is 2. So y is equal to 2. We're not quite done though, because we need to solve for x and y. So we've solved for y, so we end up saying sub y equal to 2 into, now we can do into either equation 1 or equation 2. The easiest one is to do 1 in this case. So let's substitute y equal to 2 into equation 1. So I'm rewriting equation 1. X equals 4. So this is coming from up here. Where I see y now, I'm going to put 2. That doesn't mean 42 though, it's 4 times by 2. So 4 times by 2 because it's 4 times y. Plus 1. 4 times by 2 is 8. 8 plus 1 is 9. So we finish it off by saying, therefore, the simultaneous solution is x equal to 9 and y equal to 2. Now I haven't shown you, and I probably should show you, we can check that this is the correct answer by substituting both values into both formulas and making sure that it actually works. So I don't mind seeing this in a test. Let's do check here. Equation 1. Now we said that x is equal to 9, y is equal to 2. So that should make this equation right. So x equals 4y plus 1. Let's just double check that. We got 9 on the left hand side because x we said is equal to 9. On the right hand side, if we put y equal to 2 on the right hand side, we've got 4 times by 2 plus 1, which is also equal to 9. So in equation 1, the left hand side is equal to the right hand side. So that's good. That's what we want. Let's check equation 2. Well, let's look what we've got on the left-hand side. On the left-hand side is 2 times by y. So 2 times by y is 2. How about I show you what the equation is? The equation 2 is this one here. 2y minus 3x equals negative 23. Well, the left-hand side, we've got 2 times by y, which is 2. Minus 3 times by x, which is 9. So the left-hand side is 4 minus 27. 4 minus 27 is negative 23. The right-hand side, well, the right-hand side's over here. It's already equal to negative 23. So left-hand side is equal to right-hand side on both of them. So we know that we've solved that pair of simultaneous equations. Alright, that's the end. If you want more of these to do, you can go to the textbook. I think it's exercise 1, might be 1H. Not sure. Have a look, you'll find simultaneous equations, substitution, you can do it. Boom. End of the video.